My name is Robert Rice. I graduated from the University of Connecticut from the Chemical Engineering Department in 2005 with a doctorate degree in chemical engineering. I graduated from Virginia Polytechnic and State Institute in 1999 with a bachelor's degree in chemical engineering. I spent a little bit of time after that working at a major manufacturing plant as a process engineer. During that time, I worked, a good job and had a lot of fun, but I really wanted a little bit more out of that particular area of expertise. I studied primarily and worked primarily in the field of process control, which is a very, very small niche within the chemical engineering field. And I had met a professor at the University of Connecticut at a conference in Texas, Professor Doug Cooper, who was a chemical engineering professor with the field of process control. He convinced me at the time to pursue a graduate degree in chemical engineering. I joined the University of Connecticut graduate program in 2000 with a focus on process control. And one of the reasons that I decided to join the University of Connecticut was that they had a very strong relationship with a lot of industrial customers and industrial advisory board, which gave a lot of the research and study programs that they have here a real practical edge. During my time at University of Connecticut, my research lab worked in the area of process control. And during that time, we developed training curriculums and software technologies that are used for process control modeling and optimization. The product had been used at a number of different companies, and near the end of my graduation, it was thought that this would be a really interesting product to go to market with, to actually start a company with it. Having an engineering background, a small company was really interesting to me because it gave me the opportunity to really be involved with a lot of different aspects. The company that I started with my business partner is called Control Station. We focus on software technologies for process control optimization. What that means is we can show up to a chemical plant, tie in our software with their control system, be able to do modeling, tuning, and optimization. What that allows them to do is operate closer to their most efficient points. We can tighten variation on their control loops. So instead of their temperature fluctuating 1 or 2 degrees, we can get it down to 1/10 of a degree. If you find yourself operating closer to those targets, you can operate more efficiently and you can drive more dollars out of your particular units. And that's what our company focuses on. We are innovative in this particular field because of a lot of the IP, the intellectual property that we have that's associated with the modeling of the process. As we started exploring the concept of putting together a small company, it became pretty clear that I didn't have all of the skill sets required to actually run the company on a day-to-day. And while I could take the time and learn and take business classes, I really wanted to focus on a lot of the engineering associated with the company, which allowed us to go and look at other departments within the university to try to find a candidate who could manage the business side and actually be able to grow the company. And that really allowed me to focus on the technology, on making the product better, and allowed me to focus on that particular aspect versus growing capital, finding investors, and building that particular business plan. I was involved in a lot of aspects of that, but solely from the technical side and helping to find the solution and to find the problem to be able to build it. That really allowed me to focus on the engineering side, which was my greatest interest. When I worked for this large company, we were very focused in what we did. You knew every day what your project was going to be. You knew what your process was. You knew you were working on a particular unit, and that was the unit you were going to work on forever because that's what they had there. And while that's interesting to some to become a complete and utter expert in one particular small minutia, I really wanted to focus on a wider area of expertise. I wanted to learn as much about everything as possible. And when you work at a small company, especially one that's in an engineering mindset, you really get to experience a wide berth of different types of products. I've been to oil refineries on the North Slope of Alaska, to beer conferences in Hawaii, and I would have never had that experience if I would have stayed at a company that focused on one particular type of product. One of the biggest challenges working for a small company is the relative unknown of the future. When you're a small company, every day makes or breaks your business. When you work at a large company, you may be concerned about a layoff or your stock prices and these types of things. But when you're at a small company, every single thing that you do has an impact on the company's well-being. If you don't show up for work, there aren't 20 other employees to do your job for you. You are it. And while we're not a one-person or two-person company, we are 12 people. It's still every single person has a role to play, and it becomes critical that each person shows up and does their job. When we go in as a company and deal with our products, we typically deal with the people in the front office who are dealing with the day-to-day business operations of their company. And they speak a completely different language than we do as engineers, and it's really important to understand those languages. And when I first started this, it took me a good year or so to really pick up on a lot of the nomenclature and verbiage and the things that they're looking for improvements, because they don't necessarily see a decrease in temperature variation as excitingly as I do. They see it as, well, what is the cost per dollar of our product that is reduced due to this temperature decrease in variation? That's what they see. That's not what I see. So going back and looking at it from the business aspect really gives you a better grasp of what your product can actually do to impact these other companies' bottom line, and that's how you sell your product. It can be the greatest engineering product in the world, but if you don't understand its impact on the financials of some other company, you'll never be able to sell it. Make mistakes when you're younger. When you start a small company, they may succeed, they may fail. You will go through your life and you will have a lot of different jobs. That's the way the market is. 40, 50 years ago, people would go and work for a company and they would work there for 40 or 50 or 60 years. These days, people do not stay at the same job for the same period of time. They stay for 5 years, for 6 years, and they move on. They're constantly trying to find what is interesting to them. You're young. You've got the rest of your life to go ahead and find that one more stable job or that stable startup company that you want to work for. Take the risks when you're young because you can afford it. You make a mistake, you find another job, you move on. No big deal.